I eagerly awaited the 2016 ZX-10R, because it is Kawasaki meeting Yamaha's new electronics-rich YZF-R1 head-on. Kawasaki's Jonathan Rie is World Supers champion this year, and Yamaha will jump back into that series in 2016, putting new action into the leader bike category. Competition drives development. This economy cannot support the tooling of all new bikes, so Kawasaki has used the rider electronics and hardware derived from 4 years in the Superbike World Championship to transform the existing ZX-10R. Every motorcycle manufacturer has its own vehicle dynamics model, and those in racing now base their control electronics on it. The model is a mathematical construct that applies physics to predict machine behavior. A first priority is to know the bike's orientation in space, which on this ZX-10R is handled by a Bosch 5-axis inertial measuring unit (IMU). It combines 2 laser ring gyros, 0 moving parts, and 3 accelerometers to measure the machine's orientation and motions in space. Computations made in the ECU convert signals from the 5 sensors into orientation, velocity, and direction. Why only 5 axes when other such systems have 6? Kawasaki's WSB-derived software calculates the 6th axis, yaw, from pitch and roll data. Kawasaki say that with IMU data plus sensors for wheel speed, brake line pressure, throttle angle, and engine RPM, it can derive a high level of chassis orientation awareness, allowing the ECU to account for track gradients and camber, tire wear, tire profile, and tire compound. Although the available press material on the new ZX-10R isn't easy to interpret, what it seems to be saying is that Kawasaki has dug deep into its actual racetrack software, rather than producing the usual production-level system relying on preset limits like some competitors' systems. Before tabulating the other electronic systems, let's look at the 2016 Kawasaki ZX-10R's new track-oriented suspension. In talking with 2013 champion Tom Sykes and engineer Marcel Dinker at the World Supers round at Mazda Raceway Laguna Seca, we learned that Showa had brought something to one of the team's track tests that was instantly worth 0.4 of a second per lap. That something is Showa's balance-free fork, BFF, and balance-free rear cushion, BFRC, rear suspension unit. Their use on the 2016 ZX-10R is their first appearance on a production bike. BFF technology was first seen by the public at the 2014 EICMA show. These are pressurized twin-tube dampers that place no valving on the damper piston. Because they display maximum fluid volume in both compression and rebound, they can be made quite sensitive. Kawasaki says this suspension is derived directly from World Superbike racing. The ZX-10R engine retains the previous 76.0mm x 55.0mm bore and stroke, but with revised intake and exhaust ports, both of which are now polished. Combustion chambers altered to permit fast burn with a higher 13:1 compression ratio, new and lighter cast pistons to match, and altered cam profiles with increased valve overlap timing. Fast, efficient combustion depends upon giving combustion chamber and piston crown complementary shapes with dimensions tightly controlled. This used to be up to the teams, CNC milling machines and operators who weren't afraid to use them. But new Superbike rules requiring stock pistons compel this work to be adapted to production. Intake and exhaust valves are titanium, and the exhaust valve diameter has been increased to 25.5 millimeters. The new head also has enlarged coolant passages. Durability has been boosted by increased cylinder wall thickness. Every manufacturer keeps a close eye on reliability, both in the field and in racing, and areas of possible improvement are attended to periodically, as we see here. What Kawasaki calls new electronic throttle valves is actually a throttle-by-wire system by which the throttle angle can be modulated for various purposes by the ECU. That serves the usual electronic aids such as SKTRC traction control, KLCM launch control, and KEBC engine braking control. When engine torque reduction is ordered by the ECU, a mix of ignition retard, instant in effect but smaller in amount, and throttle movement, slower responding but greater in effect, results. The traction control offers 5 instead of the previous 3 modes, and a new predictive/feedback system is said to maximize acceleration. KEBC engine braking control, as first seen on Ninja H2R, cracks the throttle just enough to prevent hopping or dragging of the back tire on hard braking, in circuit use only. KLCM launch control has 3 intervention levels. Selectable power modes are full, 80%, and 60%, as chosen by rocker switch on the left bar. ABS is an option, and with it comes a cornering management function intended to reduce the bike's normal tendency to stand up when braked in corner. Stand-up results when braking force, acting off-center on the leaned over front tire, steers the front end into the turn, making the bike lift. CMF reduces this by distributing optimum hydraulic pressure to the calipers, based on the motorcycle's lean/pitch angle. The desired result? That the machine holds line rather than running wide. Chassis changes, too, are likely driven by Kawasaki's World Superbike experience. To increase load on the front tire, which keeps it steering under higher off-corner acceleration, the steering head has been moved back 7.5 mm and the swing arm lengthened 15.8 mm. More powerful braking is provided by 2 330 mm front discs, 310 mm on previous model, and M50 Brembo monoblock calipers with 30 mm pistons. An Öhlins electronically modulated steering damper with revised settings offers easy steering at low speeds, adding damping as required by higher speed, acceleration, or braking. We can all be pleased to see the continued translation of racetrack technologies into increased capability and security for riders of production machines. Racing solves problems for racers, and production offers those solutions to all riders.